welcome after lunch. Welcome to my talk. Welcome back after lunch. I hope your meal was nice and you're not too tired now. Because it's quite a interesting but also not a very complicated topic. And I have lots of slides, and I will also put these slides later on the internet. You can download them, can have a look at some of the examples. Maybe I have to rush through some of the examples because I don't have that much time. I'm Falk. I live nearby in Darmstadt in Germany, next to Frankfurt, and I'm also part of the Java community. We have a Java user group in Darmstadt. There's next week the next event. Maybe you're also nearby and can just come by. Would be nice to see you again next week. And we have also a kind of online community. It's called Cyberland. There we have an event only with speaker women, and we have also monthly open source code camps. Yeah, why I'm standing here? About 15 years ago, I started to fall in love with Groovy. It was an alternative language in the Java JVM area, and I really liked Groovy. Groovy was not a functional language, but they had lots of concepts which come from the functional programming. And I started I was part of kind of study group where we tried to understand how functional programming worked. It was also 10 or 12 years back. And I also tried to learn it in an online course at the TU University of Delft. And then there was a real nice example. You will see this example later in this talk as well. And I made my first talk about functional programming, just showing how this could be in Java, this example. And I called it a JVM functional language battle because I tried it in Groovy, I tried it in Scala, I tried it in Closure and also in Java. And yeah, that was kind of talk 10 years ago, which this one is the successor, kind of. Yeah, we want to talk about functional programming. Why is it important? Is Java not functional already? I don't know, maybe. And I want to show you some more complex functional concepts, which we can also use in Java, but maybe not that good, like in a real functional programming language. And yeah, that's the timetable for the next 35 minutes about. Why functional? What are the problems with object-oriented programming? Most of us will work with object-oriented languages all day. And why is functional programming better? And I want to show you some of the problems of the object-oriented style. There's a little example here. I've hidden the real purpose of this algorithm. So I called it foo algorithm. You will see what is it all about in a few seconds. So when you see this example, you will maybe think about it's kind of spaghetti code, so lots of lines and not that easy to see what it's all about. And actually, it's so-called Loon algorithm. Maybe you've heard about it. It's about calculating checksums, for example, for credit card numbers. So if you put in a credit card number in a formula, then in a form on a website, then they can check if you have just mistyped or have switched to numbers or something like that. And you can do it client side. It's just an algorithm. You don't need a server for calculating these checksums. And how does it work? There's the example again. There's quite a few steps. The first step is you have split this whole 16 digits into single digits numbers. Then you have to reverse it, and every second digit has to be doubled. Then you have to sum it up, and then you have to check if it's modulo 10 equals 0, so if it's divisible by 10. And if it's modulo 10 equals 0, then it's valid. I have an example here, and we will see some more code examples about this Loon algorithm, so that's the imperative way of doing this. And maybe if it's too fast, just look at the slides later. You can just see how this algorithm works with about 7 steps here. And you already saw that in an imperative style, it's quite difficult to see these steps. So it's a bit weird. It's not in a sequential order. And there are some more problems in object-oriented programming, like we have variables, we have kind of state, changing state, we have loops, we have conditions, we have nesting and maybe some deeper nesting. We have changes of the status of the variables. We have not this sequence like the algorithm is actually defined. And error handling isn't missing here, but we also have to think about it. There are some kind of exceptions we regularly throw in Java, but that's also not really a good example because it's called a side effect. We see that later. So that's a really old example. Maybe it was in Java 1.2 or something like that. And all of you will say, yeah, right, Java 8 is already functional. Why don't you use stream API and Lambda expressions and so on? And you are right. There is, in the last 10 years, or 12, 15 years, starting with Java 8, there are some more functional concepts coming to Java as language. And the Java 8 was only the first step, and we will have a look how it works now. But we will also look in the future of Java, and maybe you're already using Java 17, Java 21, then you can also use some of these ideas, and we will see how functional Java is at the moment. What are these concepts? They are already in Java since more than 10 years. It's not a secret, you all know it. You can use stream API. In this example, it's also the Loon algorithm. I split the credit card number in character, then I map it to get the numbers, the actual number values, and then the same steps we already saw will be, we have the same steps. And there's one problem inside. When I make it in this way, then I have still a state change or change of state. It's a bit hidden, and it's also like kind of workaround because we can't change variables inside the Lambda expression, which are defined outside, so they have to be final. But I have a trick. I just use a kind of container. In this case, it's just an int array, and inside the int array, I can change the values. The int array itself can't be redefined, and that's not really nice, but it's kind of workaround, and it looks much better, I think, because we have already the sequential order of my steps, so I can see how this Loon algorithm works in my application here. A friend of mine, Thomas Much, saw this example in one of my talks 10 years ago or whatever, and then he came with this solution and said, you can also get rid of the change of state, and you can use something like a generator. It's a primitive iterator of int in this case, and that always gives me a 1 or a 2 and a 1 again, 2 again, and then I can just use it to double every second digit. That's the thing I want to arrive to. Good. It's kind of, I didn't translate it to English. It's kind of never-ending stream. Or it's kind of lazy evaluation. It's not evaluated at the beginning. It will only evaluate it when you get the values of the stream, and it's only 1, 2, 1, 2, 1, 2. How it doesn't matter how long you retrieve the numbers. So that's quite nice, but it's very old, and we won't have a look at this now because there's some kind of, or a lot of things missing which are also very important in functional programming. And here are some examples like immutability, like persistent data structures, like side effects, pure functions, like lazy evaluation, like currying, partial function application, like pattern matching. And all of this I want to show you in the next minutes. And I know that's much, a lot of things, but I hope we can go through it. And Java actually isn't a functional programming language, and it won't be a functional programming language in the future, but it gets more and more features which comes from functional programming languages. And there are also some frameworks, some libraries like Waiver, like Lombok, like immutables, and there are lots of more. And there are some more progress in the Java release updates in the last years, like Java 21, which is the latest long-term support release, which also comes with some nice new features like records, like pattern matching, and we will have a look at this as well. And I know records are also part of Java 17, but they are part of the whole thing called pattern matching, so it's only one single part of it, and so I decided to say Java 21 is the minimum to talk about here. And there are also some more libraries in Java which we can use to simulate or to use functional concepts, but I won't speak about this here. That's too out of scope for this talk. So let's have a look what is functional programming all about. And first I have a nice sentence from Gernot Starkey. It's he's famous in Germany for software architecture. I'm also actually I'm not a Java programmer anymore, but I work as a software architect, as a consultant, as a trainer for software architecture. So I'm kind of colleague of Gernot now, and he said to understand recursion, you need to understand recursion first, and that's part of the problem. Understanding functional programming and recursion is one of the key concepts, in my opinion, in functional programming. It also works for imperative programming, but it's also a very important concept in functional programming. And yeah, understanding this is quite hard. And we all know how recursion works, but there are some more things to have a look at. And that's the road we want to go through in the next minutes. Maybe we won't reach all these sub-chapters, but yeah, we will talk about most of them. And you already saw this little example, the imperative loon algorithm, and we want to make it more functional in the next minutes. And yeah, it's kind of validator for credit card numbers. They go in, and then I have maybe a credit card number class, where I can call validate, and then maybe the first one is valid, the second one is not valid, and so on. Yeah, let's talk about mutability. I think that's also a quite good concept we already understood. So we can make it short maybe. It comes from, or the idea is not that new, but it also comes from the book Effective Java, which is, I mean, a must-read for all Java developers. And they have kind of blueprint how immutable classes look like. The blueprint is here. We don't have to go through it now. We can look at it later if I'm not sure how it works. And fortunately, you don't have to go through this blueprint because there are some tools like Lombok, which is already also 15 years around, where you can use meta like annotations, so meta informations, which are at the compiling, which will where the functional the immutable blueprint will be made. Sorry, my English is a bit rusty today. I'm not used to speak English in my day-to-day business. And Lombok, I know, maybe some of you are fans of it, some don't like it. There are some problems with Lombok I don't discuss here. Maybe we can discuss later after this talk. And fortunately, there's some new feature in Java, also since 5 years now, since Java 15, I think. It's called records, and I said, yeah, it's part of this whole thing, pattern matching. So in Java 21, you can use all these stuff, and then it's quite easy to have in a class credit card number, which just one number, actually long value in this example, and that's it. You can also have a so-called compact constructor for validation, for example, to see that the credit card number is not too small or too big. And then when the constructor is invoked, then you can just throw an exception. That's not really functional, but it's an easy way to do it in Java. Yeah, what are records? Records are like tuples with a name. There is no tuple class in Java actually, but there are lots of libraries where you can have tuples. But now there is a kind of feature in Java which you can always use when you have Java 15 or newer, which have also this characteristic of tuple. So you can have different data types, small data types, which has many components, and you have just one single line to create or to define these classes. Actually, record is also a class which applies these immutable blueprint we already saw. And you can also nest records, so you can have a rectangle record which uses point record, which is, that's also quite easy. It's minimal, compact, concise, transparent tuples of data, immutable. We can use it in DDD for value objects, for example. We can use it when we have to map values with data transfer objects. We unfortunately can't use it for JPA entities, but we can use it for projections. Maybe you know this kind of thing, but it's also kind of data transfer object when you query the database. Yeah, what does the compiler make out of it? Yeah, he generates from these records, of course, some more methods like equals, hash code, like accessors. They don't start with get, so the get is lost, but it's just the name of the component, value, currency in this example. And we always have a canonical constructor, which takes all of these components, because we have to construct it when a constructor is or when a new instance of this record is evaluated or something like that. And there are some more possibilities. I won't talk about this today, but you can have more constructors, you can have methods, and so on. There are some drawbacks, but not that really important, I think. So instance methods, constructor overloading, or this compact constructor to make some validation, for example. So that's quite easy to have immutability in Java now. It was more complicated 10 years ago or 5 years ago when we don't had records already. So let's go to the next step, and the next step is also quite easy, and I think we all know about it. Maybe we don't call it that way. It's about pure functions. Pure functions is ideally you construct your program only using pure functions, and pure functions means you have no side effects. And a side effect is when something other happens than just a result is returned. And I have some examples here. If you modify a state, a variable, if you throw an exception, if you print something on the console, or if you write to a file, for example. And let's have a look at this little function. It doesn't look like that it has side effects, because it has some input and dividend and divisor, and it just apply dividend divides divisor and returns the value. So also if you don't have a return value, if you just have a void function, then it always has a side effect, because when nothing returns, then it must have a side effect. But here, I think most of you already saw, is the problem that the visor can be 0. And if it's 0, then an exception will be thrown, and that's, of course, a side effect. Just in one case, not in all of the cases, but in one case, there will be a side effect. And we have some examples in Java, in the JDK, in the Java runtime library, like math.random. That's, of course, not side effect free, because random always returns another value. That's the purpose of random. But another example, and math.max, I want a maximum value between 1 or 2. And that's, of course, is free of side effects, because when I put the same values again and again, I get the same result back. And there are no side effects which I'm aware of, that it will throw an exception or something like that. I'm not sure, but I think there is no. And we can, of course, use it and write our own functions, pure functions in Java. Here is the isValid function for our credit card number, which checks if the credit card number is in the right range. And unfortunately, there is no real support in Java for pure functions. But when you make your function static, that is not sure that that has no side effects, but it's always a good thing, because you can't change the state of your instance then. And you need a return value, so a void, and you don't have to implement state changes, side effects like exceptions. And then, yeah, that's quite easy to have also pure functions, although it's not supported by the language itself. And I think, and we could stop here, immutable data types, so your own data types, when you implement them immutable, and this referentially transparent, and that means pure functions. If you just use these two advices, then you will make much more of your source code, and it will be more readable, more maintainable, and so on. But I have some more features for you, so we are not finished now. But it's that easy, actually, and maybe that's the 80% solution, and the next 20% needs 80% of our attention now. So let's go to so-called functional or persistent data structures. And we know Java collections. It's a very nice library, the Java collection API, but it has one drawback, and Java collections can be modified. So there is some workaround that we can have collections.unmodifiable list, set, or map, or something like that. But we all know it's just unmodifiable at runtime. So it's not, the compiler doesn't complain if we modify it. We get an exception then most of the time at runtime if it's not allowed to add or to remove items. And that's not very nice, because we want to catch our programming errors very early, because if we catch errors more earlier, then it's cheaper to make them away. Sorry. And Waiver, I already told you, is one very interesting library. It's also about 10 years old now, and I just saw that it has a new maintainer. So if you don't Waiver now yet, then just have a look at it. If you have seen it a few years ago, you should have a look at it again. And Waiver comes with so-called persistent data structures. And persistent data structures, try to are immutable. So there are the drawbacks that if you add a new element, then there has to be a copy of this data structure, because you can't modify the original one. But they try to implement it inside very efficient. So you see here, when you add a new value or prepend a new value or something like that, then just two or one element is new, and just we have two references, and they reuse the data, for example. And that depends on the data structure. So there are different data structures like lists, like sets, like maps, and so on. So it depends which data structure you use, which kind of optimization you get. So there may some data structures which won't work good with immutability, but if it's important for you that your data structure is immutable and you also need some kind of performance, then you have to watch out which data structure does fit for your purpose. And we have a second problem when we use waiver. I really like waiver, but we have a second problem. We have to map between the Java collection API, which is kind of built in, and we always use Java collection API when we also talk to other libraries or to other code. And when we want to use waiver, then we have to translate it from the one side to the other. That's also kind of problem, I think. But yeah, it's always kind of trade-off when we use such things. Maybe you are asking what is waiver all about? What does it mean? Waiver is much more than just these persistent data structures. Waiver is actually was called Java slang. So it was a kind of library to improve Java's functionality in kind of functional programming. And Oracle was not amused because of this name, Java. So they have their trademark, and their lawyers said to this, it was a German guy who started waiver, and so he had to change the name. And when you just put your head down, then you see it's Java on a head, because he had a sticker on his laptop, and when he just closed it, then he saw it on the wrong direction, and so the name was created. Quite funny story, I think. Okay. That's very short first example for persistent data structures. I know there's lots of more, but we want to go further. I have some more input for you. And the next one is higher order functions. You already know them, but we want to talk about it a bit. What is a higher order function? We have functions in functional programming which are first-class citizens, and functions can not only compute it and apply it, they can also be passed around and can be a return value of another function, for example. And then higher order function is nothing else than a function that takes maybe a function as an argument or returns a function. And we always use higher order functions like the map function, the intermediate functions in the stream API, for example, where, by the way, there's also a nice new feature in Java 22. It started in 22 and also in 23. Maybe you already saw it. It's called stream gatherers. You are able to write your own intermediate operations in streams now. So there are only limited set like map and a few more. But there's now an own API in the JDK to write your own intermediate operations. Also a quite nice feature, but we won't see it here now. So that's the same example we already saw a bit earlier with this hidden state change, bit kind of workaround. That's okay, but I want to show you another example how to implement the Loon algorithm more functional. And it's my loveliest example in this talk. It's about zipping, like the zipper of my hoodie here. And you have two data structures, one on the left side, one on the right side, and you zip them together. If you take the first one of the left and the first one of the right side and put them together, and the second one, and so on and so on. And I have a very simple example. Maybe you already saw it, maybe not in this way, but in an imperative way. It's called FizzBuzz. It's one of the famous code cutters when you just try to improve your coding skills, and you have to print the numbers from 1 to 100, and if the number is divisible by 3, then you have to print fizz. Or if it is divisible by 5, then you have to print buzz. If it's 3 and 5, then FizzBuzz, and otherwise you have to print the number itself. And you can implement it very easy with a loop and some if statements, but it's not very functional. So we want to see how that example could be in a functional way of programming. And there, maybe you have already seen it, we have 3 data structures. One data structure which is lazy evaluated with 2 times 0 or a string, an empty string. And the third one is fis, but it's an data structure which can be repeated. So you have the 4th and 5th is empty again, and the 6th is fis again. And the same we have for bus, but the first 4 elements are empty strings, then bus. And we have a data structure which is also I'm sorry, I'm missing the word, but it's a data. It's kind of list. It's a stream which starts at 1 and it can can get until don't know. No? What is unendlich? Help me, please. Infinity. Thank you. Thank you. So it's infinite data structure. And now I can just zip all of these data structures together. First I zip the fises and buses, and then I have a data structure which have 2 times empty string, then fis, 1 time empty string, then bus. And I can also put that together, zip it with the infinite, I know, infinite data structure, like the infinite stream from beginning with 1. And then I have an infinite data structure which has 1, 2, fis, 4, bus, and so on. And then I can just say I want to take the first 20, for example, or the first 100, whatever, and print them out. And that's really nice. Here's the, just try to visualize it in another form. Maybe it helps you to understand the example, but also you can just have a look at my slides later on. And I really like this example. And we can also use it for the Loon algorithm. So here we have the double every second digit. And in this case, we can have also these infinite data stream 1, 2, 1, 2, 1, 2. And we zip it with the 16 numbers of my credit card number. So that's the same idea. And here you see, I think that's I must remember, but I think that's the implementation in Waiver. Waiver is a bit more concise. If you can also implement it in Java, in pure Java, since Java 8 with Stream API, with functional interfaces and so on. But it's because also of the typing, you have to generics and something like that. It's less more readable than it's quite blown and not very concise. But that's Java, and we can use it in Java as well. It would like much more easier or nicer in a functional programming language like Haskell, for example. So I think I don't have much time, so let's just go further. The next one I want to show you is function composition and function currying. It's actually 2 topics, but I want to show you them in a few seconds here. Function composition is kind of reusing things in functional programming. In object-oriented style, we have inheritance, which is also a kind of reusing, but we don't use it actually because it has some problems. In functional programming, I have very small functions, and I compose them together to get a new implementation which is more powerful. Actually, it's the same we know from Unix and Linux command line when we pipe different operations together. That's the same idea. And we can all already use this in Java. That is a compose or and then. It's actually the opposite, compose or and then. I can use both of them. I use and then here because it's a bit more readable then because it's something like this picture here shows. I have many functions and I have my credit card number, which is on the bottom right. It's called n, and I put it in the first function and the result in the second function, and so on. And I can write it in this way. I have many functions. You will see the functions in a few seconds. One function is 2 digits, another one is called reverse, one is double second. Actually, they are lambda expressions. And then I can just compose them together. And actually, there's also a compose method, but I use the and then, which is the opposite. So it's easier to read, I think. And I could also have done it in this way. You see on the bottom, I could just say there is 2 digits n, and I have the parentheses, lots of parentheses here. And then I get a new function which is called isValid, which is the sum of many functions in this way. And now, and I know it's lot of code, so maybe here as well you have to look at it later if you have more time, next week, for example. But here are all the small functions, which are, each of this function is one step of our Loon algorithm. So when you look back at one of my first slides, then you saw the Loon algorithm, and here you can see the implementation in Java, actually also in Waiver. It's a bit more concise, a bit shorter than the, when I don't use Waiver, then it's more, it's a bit more code then. So I can't go through all of them, but actually, there is also my zip again, and you already recognize that zip is my loveliest feature here in this talk, and it's quite in the middle, so maybe you have already spotted it. So, what we didn't talk about was currying. So let's just have a look at currying. Currying comes from a very famous person who is called Haskell Curry. So his first name is now a Java programming language is called after him, and his last name, Curry, that's a kind of method where you take a function which has multiple parameters and you transform it to single functions with only one parameter, which are kind of composed then or something like that. And that brings us to another way of reusing in functional programming. You can have a bigger function with lots of parameters, and then you can just curry it and bind to single parameters a value. So then you can get a partial function application. And you get from one function smaller ones which have already kind of default values which I bound to the parameters. Yeah, that's the short form. Maybe we can't go in more deeper, but here's an example as well. So maybe you can have a look. My zip with 4 parameters here, but the first parameter is actually a function, and then I have 2 parameters, list 1, list 2. And when I curry it, then I have one function which gets one list, and then the result can I put in the next function which also get one list, and so I have 2 functions with 1 parameter each instead of one function with 2 parameters. And then this leads us to use partial function application, and there's also an example here where I can just call the function with the first parameter, and then I get a new function which only gets where 1 parameter is left, which I can reuse later. So that's also a very nice feature, but maybe too less time to show in more detail here. So please have a look or come to me. We can talk about it later if maybe it's too fast at the moment. I'm sure for me it would be too fast 10 years ago when I started to think about these cool ideas and concepts. Yeah. The last 2 topics I brought with you is about algebraic data types and monadic data types. I'm not sure if I call it right, but it's about, for example, how I can handle exceptions, errors, and algebraic data types. We see another example in a few seconds, but examples from Waiver, from this library, is that I have a try, an ASA, an option, validation. We all of us can know about optional. It's also kind of algebraic data type. where I have kind of choices. I can only have two values, for example, and there's no possibility to have invalid states and something like that. So it's a very important feature. And actually, since Java 17, I have some new features in Java like records. We already saw them, and sealed classes, where we can now also implement such kind of algebraic data types. And in a very simple example for our Loon algorithm, I can just, instead of throwing an exception in my validation of the credit card number, I can just return a try value, which is kind of valid, or if it's not valid, then it's kind of error state. And so I have always the same value, but with maybe two kind of content, and I have to decide which one I get, if it's an error or if it's the real value. And since Java 17, actually, I've written 21, but 17, I can also implement this in Java with algebraic data types. There are some types and product types. Some types are sealed classes. That means that I have multiple types, which are either the first or the second or third one. And product types are like records, where I have one type which has many elements, which are the product of all the components, is it called in records, is represents the state of this type then. And how does that look? Here I have a very simple example in Haskell. It's a list, a linked list, which consists of a null list, an empty list, and the so-called cons operator, which constructs a value to another list. And when I implement, or when I want to define a list in Haskell, I have to call a nil empty list plus the first value, and then I can just add other values. And of course, I don't have to use this line here in Haskell. There's some shorthand now. I can just use the colon operator, or I can just write also like we would do it in an array in Java. And how does it look in Java? I have to hurry up now. I could just have a kind of inheritance hierarchy. I have an interface list, and I have two subtypes, nil and cons. And this would look like in this example, interface list permits is a sealed interface. Only two values, two subtypes are allowed, and no other subtypes are possible. And if I switch over these kind of data structure later, then the compiler knows if I have all of these case branches I have already applied to. So maybe it's also a nice example. You also have a look at it a bit later. Here's the full code example, and I've also a GitHub repo where you can find all of the code. And here you see that we need kind of factory method off, and to construct, because there is no easy way to construct this kind of data type or elements of data type. And when I want to implement operations on that data type, I would do it in a functional way, because I don't want to put the operation inside the data type, so I put it outside as a static pure function, which has two parameters, the list itself, and in this case needs a value which I want to ask if it's part of the list. And that's the last slide, pattern matching, where I can use in contains the new switch expression, the sealed classes, the record types, record patterns, and so on. You see some examples here, type patterns, record patterns. And then it's quite easy to switch over these linked list and calculate if the value is contained or not. And there are some more the progress goes on. In Java 21, there were some unnamed patterns, and in Java 23, there were primitive type patterns. So there will be some more features in the near future. So that's all. Maybe you've already seen the learning curve is quite steep to learn functional programming, but it has some very good benefits. It's a different kind of work, how we work when we work imperative or functional. Imperative means how do I reach my goal? Functional means what do I want to achieve? So it's another kind of working. And there are lots of benefits, easy to understand, easier to test, easier to maintain, higher code quality, and so on. And that's it. Thank you for being here. For the German-speaking people, I have some announcement. There's a small Java software architecture online conference in December. Maybe you are interested. Then just have a look. And the slides, I will share them on our website, embark.de/download. So you can have a look at it maybe in 1 hour, and we'll upload them in the next hour. And I will also give them to the organizers of OCX. And I have some, for German-speaking people, I have some more cool stuff about software architecture. So just feel free to come in front of here and take some examples. Thank you very much, and enjoy the last part of the conference.